the title of Chapter 9 is Chemical Reactions and Equations. After you complete this chapter, these are the learning objectives that you will be able to understand. First off, we're going to learn how to balance chemical equations that support the law of conservation of mass. You will be able to write and balance chemical equations. You'll be able to classify a chemical reaction, and you'll be able to predict the products. Now, in just this unit of notes titled moles and grams, we're going to look at those coefficients because the coefficients can actually represent a couple of different items, and we'll get to that later in the video. But the coefficients are used to balance chemical equations that supports the law of conservation of mass. And recall that the law of conservation of mass states that in a chemical reaction, ordinary chemical reaction, that a mass cannot be created nor destroyed. Now, in nuclear, that is not the case. So in a regular chemical reaction, the mass of your reactants must equal the mass of your products. So that means that simply your atoms are being rearranged to make new products from your reactants. So I like this picture because it shows you how we are making water. Our two reactants are diatomic hydrogen and diatomic oxygen. We specifically need 2 molecules of diatomic hydrogen and 1 molecule of diatomic oxygen, and together they will produce 2 molecules of water. So if we look at the individual atoms, we have 4 hydrogen on our reactants and 4 hydrogen on our products, and then we have 2 oxygen on our reactant side and 2 oxygen on our product side. So they just simply rearranged to make new molecules. To understand what's going on and how mass is not being destroyed during chemical reaction, we can calculate what's called the molar mass, the mole mass, or formula mass, or it means the same thing, or the same technique. It's just what type of compound are you working with? Is it a molecular compound or an ionic compound? So how you do this is you're going to need a periodic table. So if you don't have a periodic table handy, I'd like for you to pause the video and pull out a periodic table. Okay, so this is going to look very similar to how we drew Lewis structures with the beginning technique. The first thing you're going to do is you're going to list, sorry about that. You're going to list the individual atoms that you have in your compounds. So we have carbon and we have oxygen listed in the formula, and I will give you the formula. Then the next thing you're going to do is you're going to write down, well, how many carbon do we have? We have 1. How many oxygen do we have? We have 2. Then you're going to go to your periodic table and you're going to look up the mass of carbon. On the periodic table, carbon has the mass of 12.01 on the table that I am working with. Remember, your mass is going to be your number with a couple of decimal places. And remember, we're going to round that to the nearest whole number. So we're going to round that to 12. Oxygen has the mass of 16.000. Some of them might have 15.999. But anyway, we're going to round that to 16. Then we're going to multiply across. 1 times 12 is 12. 2 times 16 is 32. And we're going to add going down. So the molar mass, formula mass, mole mass of carbon dioxide is 44 grams of CO2. What I would like for you to do is pause the video, and I would like for you to calculate the mass of C6H12O6 NaLPO3, please. Okay, so how did you do calculating your molar mass of C6H12O6 NaLPO4? Okay, I went on and added another formula. Here we have copper 2 nitrate, and I just want to show you what do you do if you have a polyatomic ion and you have more than one. Again, you're first going to look at copper. How many copper atoms do we have? We have 1, and the mass of copper is 64. multiply going across. Now nitrogen, how many nitrogen do we have? Well, we have 2 outside of the parentheses, so we're going to distribute this 2 to our nitrogen, which is understood to be 1. So 1 times 2 is 2, so we have 2 nitrogen total. The mass of nitrogen is 14. So the mass is 28. And how many oxygen do we have? Well, we're going to distribute the 2. So 3 times 2 is 6 oxygen. And they each have the mass of 16. So our total mass of oxygen is 96. Add going down, our total mass is 188 grams of CuNO3, 2. So here's a picture representation. Remember, AMU is short for atomic mass unit. So the mass of each hydrogen is 1. The mass of oxygen is 16. So 1 plus 1 plus 16 gives us the total mass of water to be 18 grams in 1 mole. So this is leading to stoichiometry. And it is going to become much simpler now, and that you're going to really like it. Trust me. Right now, we're only going to work with one-step problems in Chapter 9. We'll get into multi-step problems in Chapter 10. So first off, this is what we're trying to find. How many moles of hydrogen? I'm not sure why that moved, but it did. And this is what we are given. We are given 5 grams of diatomic hydrogen. Now, if we want our grams of hydrogen to cancel out, remember grams are going to go diagonal from each other so they can cancel. And moles is going to go on the top. It is always going to be 1 mole. So you will take 5 times 1, which is 5, divided by 2, and our mass is 2.5 moles of diatomic hydrogen. What we're trying to find here is how many moles of oxygen we have if we're given 40 grams of oxygen. So we're going to do our multiplication sign and draw the line for equality. Our mass will always go diagonal, so we'll have grams of oxygen because we want them to cancel out, 2 moles of oxygen. And like I said, this will always be 1. Now, where do we get the 2 from up here? Well, how many hydrogen do we have in our formula? We have 2. We go to our periodic table, and hydrogen has the mass of 1. So 2 times 1 is 2. So what will be the mass that we put here for oxygen? Well, first off, how many oxygen do we have? We have 2 oxygen. They each have the mass of 16. So the mass is going to be 32. So 32 will go there. Then we will multiply going across. We're going to take 40 times 1, which is 40, divided by 32. So that means our answer is going to be 1.25 moles of O2. Okay. Unfortunately, we're not always going to give you the setup of the problem, so they could be in a word. How many moles of water are in 45 grams of water? So again, this is what we're trying to find. And this is, okay, Mr. Fine, you need to stay here. And this is our given. So we're going to start off with our equation. No, given, stay. Given. So we're going to have how many moles of water, that's H2O, are in 45 grams of water. So if we want grams of water to cancel, grams of water will go down here, and moles of water will go here on the top. Again, it's always 1 mole, and our molar mass of water we calculated in a couple slides before, which is 18. Again, how many hydrogen do we have? 2, and they each have the mass of 2, and the mass of 1 oxygen is 16, so 2 plus 16 is 18. Multiply across, 45 times 1 is 45, divided by 18, and your answer is 2.5 moles of water. We can also determine the number of grams. So in this case, what we're trying to find is how many grams of NH3, sorry, it is my shirt that keeps touching the screen, making it do that. So how many grams of NH3 are in 5 moles of NH3? So this time, if we're trying to get moles to cancel, we'll put moles in the bottom, and mass will go on the top. It's still going to be 1 mole, and the mass of NH3 is 17, because how many nitrogen do you have? 1, and each nitrogen has the mass of 14. You have 3 hydrogen that have the mass of 1, so 14 plus 3 gives you 17. Then you're going to have 5 times 17, which is 85, divided by 1. So your answer is 85 grams of NH3. Don't worry, we will work on these in class. Finally, coefficients are the numbers that are used to balance equations. So this is a coefficient right here, and this is a coefficient right here. Coefficients have to be whole numbers. They can't be fractions, and they have to be the smallest whole number. And remember, they're used so that way each atoms are exactly the same. So we have 2 times 2 is 4. And this is understood to be the coefficient of 1. You could write a 1 there, but sometimes it looks a little confusing, like we have 10 with the subscript of 2. But that is saying we have 1 molecule of oxygen. Since oxygen's diatomic, we have 2 oxygen atoms. And then let's look at our products. 2 times 2 is 4 atoms of hydrogen. 2, this is understood to be 1, is 2 atoms of oxygen. Now, these numbers, or your coefficients, are going to be representative of both molecules or moles. So that's why we are studying moles. And that is the end of our first movie.